What's up, guys? Shawnthebro here, back for another episode of the fighting game tutorial. Today we will be able to implement hitboxes by the end of the episode. Proximity, strike, hitboxes, and hurtboxes. The ones that the players can take damage from. Now, I should say that the hitboxes don't do anything on collision yet. The functionality is there, but the actual collision, the test collision with rectangles without actually doing a collision that pushes the player or anything like that is a whole nother thing. I wanted to get us started here on this hitbox track. It's going to take quite a bit today. It's probably going to be at least a 30-minute, maybe 40-minute episode today. So I figured let's get started and not go too far into it. So if there's any questions or if it's too much, we can kind of chunk it. So let's get started right away. We had, in the last episode, I showed you how to get these Mixamo characters in, and I did a separate video on where to get the Mixamo animations and characters. And now that we have them in, and we can actually use these animations with it, like this attack, for example, now is a good time to start testing, like, oh, what should happen when I hit this guy? I should damage him, right? But you're not going to know just by, like, because you could do a collision with your character and be like, oh, I collided with him, I damaged him. That would make for a not very good fighting game, if we're being honest, because here's the thing. If you do it collision based off of just the mesh of the character or something like that, it's going to cause a lot of issues with the size of the character, their attacks themselves. Like, if some of the attacks are really long as opposed to really short, you don't necessarily want those attacks to just reference what is happening with your character's body. There's going to be unfair advantages based on some of the characters. So we need to create hitboxes. So there's different types of hitboxes. I'll get you started here with just the general hitbox class that I made. So actually, let me show you, because I don't think we've done this during this tutorial. So if you hit add new, you can add new C++ class and go to for the hitboxes, I usually use an actor. And the reason I use the actor is because an actor is just something that can be spawned in the world. It doesn't really need to have control over anything, such as a character or pawn is intended to. They give you the functionality to control them, whereas with the hitbox, we kind of just want to spawn it and forget about it. We don't really care what happens to it as long as it's being spawned and the functionality within it is being implemented properly. So I would inherit off the actor. You just hit next, you enter the name and the path you want it. It's probably already in your C++ file path, so I wouldn't worry about that. But make sure you name it something. I named mine Hitbox Actor. And then here's my class itself. So you'll see something pretty similar to this without the enum right here and several of the functions I added in variables. So to start off, and this is probably the single-handed most important part for the coding aspect of it, is you're going to want an enum or some other indicator. You could do it with ints or even booleans depending on how you're doing it, but an enum is really the way to go here in my opinion, because you can determine all the different types of hitboxes that you intend on using. So you see here I have proximity, strike, and hurtbox. So proximity, I don't know if these are the proper terms. Let me say that. The reason I named these the way I did is because on Fury Strike and another fighting game that I was working on contracting for a little bit, they were called proximity hitboxes. Usually when I say that, a lot of people don't really know what I mean, so I'm not sure if that's the correct term, but to me, that's the term I know it as. So proximity to me is basically the hitbox that pops up that tells the enemy player if they should block or not, if they're going to be hit by the incoming damage. So the proximity hitbox is basically an indicator to say, am I going to be hit by this? Is this high, medium, low, all that kind of stuff. It'll give you all the information they need going into the attack. It's before the attack actually hits and damage is dealt. So if that's not the right term, I'm sorry about that, but it'll work regardless of what you call it. Just make sure you know what it is. And a strike hitbox is when the damage is actually being done and what part of the body is actually being hit. So it differs from the proximity hitbox because it's not just telling the enemy player what's going on. And it also, at that point, if they're not blocking by that point, then they actually take damage. Whereas if they're blocking by the proximity point, then they won't take damage from the strike, assuming that they haven't stopped blocking. So it's both a timer and a way to test basically different heights of attacks or if a player is going to be hit or not. The hurt box is what goes around what goes around the actual player. So around the player, you should have a hitbox because, if a hitbox is going to hit your character, you want to be able to hit them. So for example, here, if I do this, and right now, he doesn't have a hurt box around him, even though we make it, and that's why you'll see that he's not taking damage, right? Because the damage should be, basically, if there's a collision between a hitbox, a strike hitbox, and a hurt box, that's when the damage occurs. So you can't just you could just do it off the mesh, and honestly, that would be fine. But again, another issue could be if you want your characters to be all the same, or all slightly different dimensions, but fundamentally the same, and the same in terms of how they can be damaged, like height-wise, width-wise, all that. If you want those to be the same or very similar, you're going to want a hurt box. If you don't really care, you could actually just use the regular collision testing that we're going to be doing later in this video, and it will still work. I would recommend very heavily using a hurt box regardless, just for functionality down the line, and also because there's more things you can do with it than just check if there's collisions that have been applied. But technically, it shouldn't really matter. But here you can make all your hitbox states. So those are the 3 I made for today. In Fury Strike and the other one I was contracting on, there were also throw hitboxes. There were also like projectile hitboxes because those ones they have to move with an object. It could be the same as the strike hitbox, but my point is you can have a bunch of different hitboxes here, so don't be shy to experiment with that. I went ahead and added 2 functions here, trigger visualize hitbox and visualize hitbox. I'm not going to go over them today because I don't actually use them today. I will be using them in the future, but we can avoid it for now since this will already be a long video. These are important though. So I did make a hitbox type enum instance and an F vector hitbox location. So what these are, the E hitbox enum hitbox type. This is a variable that's basically just a class instance of this enum. So the data it'll have the options to be proximity strike or hurtbox. The hitbox location, on the other hand, is just an F vector, so it has an X, Y, and Z, and this is for the location of it. We don't necessarily have a way to just put it in the space, like right where his fist happens to be, so we're going to need a location to adjust where the hitbox spawns. So you don't really need to see anything in the C++ class because I didn't touch anything with it. I just added this function, but I'm not using it today, so you don't really need to worry about that. Okay. Now, let's take a look at the things I did inside Blueprint that kind of got us to where we are now. So there's a few steps we're going to need. The anim BP is going to be pretty heavy. It's all this stuff right here. Don't be scared by it. It's all pretty reasonable, and a lot of it's copy and paste. Like you'll see, these 3 areas are the same, and then this is the same as this with just a few adjustments. It's quite a bit, honestly, so get ready for it, but we're going to go over it, and if you've never done it before, don't worry. I'm going to go over in depth, and that's why I plan on making this video a lot longer than usual. I also made a Hitbox Actor BP class, which I'm going to show you how to make when we get started here. And then I made some materials just to give them color. Normally, if you're going to make a hitbox, it'll be a little bit transparent, so I will be adjusting these materials probably in a later episode, but it was already too much to be adding on top of this episode. I didn't want to add even more. Lastly, we're going to want to look at our our animations again, because last time, like, we added attack ended, I also added some more notifies. Okay, so with all that taken care of, let's get started on making the Hitbox Actor BP class. So you don't need to make a BP class if you're comfortable with coding, but I would recommend this if you're new to coding, or also just if you want to make your life easy. Let's be honest, Blueprint is easier, and anytime you have to deal with HUDs or colors or, you know, things that you're going to be seeing in the game, it's usually easier to just deal with it in Blueprint. So what I did is I did add new Blueprint class, and then you can go to, make sure you hit this all classes down, and then go to Hitbox Actor, or whatever your class was, whatever you decide to call your C++ class, and select it. I've already made mine, so I'm going to cancel. So I did a few things in here. We can go over this first. You won't be able to see anything until the very end, but this is kind of the most important Blueprint part of this, because without this you wouldn't see anything anyway, regardless of what you did anywhere else. Okay, so in this class I have a function called spawn hitbox. You could do this on begin play if you want. I'd recommend not doing that because of the way you would have to store the hitbox location. It might be a little bit weird just because when you initially spawn it, you're not necessarily going to have the location right away. And I'll explain that when we get to setting the location, but I'd recommend making just a new custom event or a new function. So you can either do add custom event, like this, it's right here, or right click and can you do a new function from here? Nope. See, I just learned something new myself. But you can go right here to functions on the left hand side and hit plus and just make a new one. Okay, to start off, what I do is I take the hitbox type, which is that variable that we defined in C++. It's that enum class instance. And I basically do a switch statement on it that determines which material it's going to be. I'll show you how I made the materials later, but just know this is a yellow, this is a red, and this is a green for Proximity, Strike, and Hurtbox. Then I just set the world location, and I set the visibility of it. This hitbox display thing you keep seeing is actually a cube that I added. It's a static mesh component cube that I added to this Blueprint class. Because if you see your Blueprint class actor in the viewport, you'll see it like this. This is the Hitbox Actor BP. So you see it's just a circle. And it will show up that way if you decide to leave it alone. But normally hitboxes aren't really circles. They're usually squares. Or rectangles. So I went ahead and add component cube, and that's this. If I could see it. It takes a second to load sometimes. If I redo this, I think it'll compile. Nope. Okay, so it's not going to show you right now because it likes doing that to me sometimes. But what you should see, if yours decides to work, is this is actually a cube now, and you can tell by the fact that the static mesh is a cube. I just did that simply because it looks better that way, and it's easier to work with than a circle. It's kind of hard to work with a circle when you have to deal with collision, and, you know, accurate collision and things like that. So all I did was add the cube, and I renamed it to Hitbox Display because it's just called cube otherwise, and we don't really know what that means. So basically set the material on the cube, set the world location of the cube, and set the visibility of the cube. Now the reason I set the visibility is because I originally have it, I spawn it for about, not even a tick before. I call this function, I spawn it when this function is called, whoops. I spawn it when this function is called, and then I set the color location and then make it visible. Because I didn't want to make it visible and have the off chance that this takes longer than expected. And then you can end up seeing the wrong color hitbox or it being in the wrong location. That looks really choppy and bad. We did that on Fury Strike originally. And there were times when it would just kind of jump around. It was really ugly. So I would suggest making it invisible to start and setting the visibility later. If you want to know how to do that, you can go to the component itself. This is the cube. Scroll down. Make sure you turn off all the collision for this. We're not going to be using any actual collision for this, at least for now. It's possible to do this all in code and just do some checks and save a lot of performance issues. But just turn everything off for now. You don't want this to actually collide with your player. It'll push him out of the way if you have any sort of like block all on, and it's really ugly. You could set it to something else other than no collision, and you could even make a custom one and ignore, player, whatever. That would all be fine. I recommend just turning it all off. We'll take care of that in probably the next episode we do of this. Anything else? Just rendering, make sure you make it invisible if you are using my method. So go to rendering visible, uncheck it. That should be everything. I personally changed the scale, so it's not a cube, it's flat in the back, because you just need a 2D rectangle to do these tests. And then I also changed the Z from 1 to about 0.535. That way it's not huge. I didn't want it to be a square. I wanted it to be more of a rectangle. Okay, so that part was pretty easy. This next part's not bad, but it is a lot to digest immediately. So let's go to the anim notifies. So the next thing that you're going to want to do is have anim notifies. Now these have to be on every attack like we talked about last time. They can be named the same thing and work properly, so you don't have to make new ones for every single animation you have. But you will need to have one instance of all of these on your animations. So attack ended we did last time. That was just when the attack was done and we decided we should go back to idle. In this case, we're not doing anything with the animations when we do the attack, or when we hit these notifies. We're spawning hitboxes. So I have attack started and attack active. So this is when attack started is when I want to spawn the proximity box. Attack active is when I want to spawn the strike hitbox. So you can put those on any of your animations and you just kind of line it up. If you pause and like go to this section, attack started to me was when I could see that he left his idle, and someone who was fighting against me in the game could tell that I was winding up to do an attack. Attack active is when the actual force would be being applied to the enemy if they were being hit. So you can see that anywhere in between here, if you're getting hit, you're probably going to be taking some damage. And then attack end, they're cleared. Okay, so that was simple, and nothing really to worry about there. Just make sure you remember to do that, otherwise your hitboxes will never spawn. If you go to your anim BP now, we can do all the logic that is required to actually set up the hitboxes properly. So let's start with attack started, because that's the first one. It makes the most logical sense. So we're going to start here. We're going to get we're going to use this event to go into a code flow that basically ends up adding this hitbox to an array. The reason I chose to do this is because you can do, for example, if you wanted to have a fighting game that has combos in it, you don't necessarily want to just fire one hitbox off and that's all. If you do, for example, if you want to do an attack that has like a guy throws 3 knives or 3 bombs or something like that, and they all have to have their own hitboxes, well, you don't want to have a system that only supports 1 hitbox per move. So you can choose not to do this. You could make 1 hitbox your move, or only have 1 hitbox spawn per move, and not add it to an array and not clean it up later. You would have to delete it at some point, because otherwise you're going to run out of memory very quickly if you're a fast-paced fighting game. But you could do that without using an array. That's fine. So what we're going to want to do is drag off of here and create a spawn actor node. Spawn actor from class node. Now when you originally see it, it's going to say spawn actor none. And then you just hover over this class and go select the class you want. In my case, it's Hitbox Actor BP. I don't really need to spawn the C++ class. I need to spawn the class that's going to have all the visuals for it to determine if it should be visible or not. and all of that stuff. The actual collision testing with the bounding boxes is going to be in C++, but we can get around doing that without spawning it here, so don't really worry about that too much. For now, just spawn your actor blueprint class. The only thing you need to change here and fill out, for now at least, is the, and I accidentally, there we go, is the spawn transform. So for the spawn transform, this is basically just your location in which you're going to spawn the hitbox or spawn that instance of that class. What I did for this is I made a variable called player transform, and it's literally of the type transform. If you make a new variable, you can see that transform is the bottom type that's not in one of the additional drop downs. All I did for this, actually, was on the try to get pawn owner, which already exists in this blueprint if you've been following along, or if you just made an NMBP that was defaulted with Unreal's blueprint nodes, you'll have this try to get pawn owner at the start, and if it's valid, if it is valid, just do a check here that's called get actor transform. So pull off here, whoops, and get actor transform, that node right there. And that return will basically get you the position of this actor, of our little mutant guy right here. This is important because this is the spot we want to start at for our hitboxes. We obviously don't want to spawn them right in the middle of our character. Then you wouldn't be able to actually move it around. If you spawned it right in the middle of your character, it's going to be way too gross and long. And if you do like a high kick, well, you don't want your hitbox in the middle of your character. So it's a good starting point. We're going to adjust it a bit here, as you'll see. But that's all you need for a spawn hitbox actor. So here's where we do the adjustments for this. Now, quick disclaimer, and I'll show you in-game. This only works if you're facing to the right. If I face this way, then it's on my right side. That's okay. We're going to fix that next episode. It's actually very easy, but I didn't want to pile it on top of everything that's already happening. Do you think you know how to fix it? If so, you can go ahead and do it. If you don't, it's okay. No problem at all. We will take a look at it next episode. But if you know how to fix it, go ahead and try it out. It's good to try some things out and just kind of learn, just kind of learn on the job, as it were. Here's what we're doing, though, to make sense of why that's the case. So this break transform that I'm doing here, I'm doing this because the hitbox location that we originally made in the C++ class, right here, this F vector, is, well, an F vector. This is a transform, not an F vector, but I prefer F vector because of the fact that transform is not usable everywhere that A vector is, to my knowledge. There have been a lot of times where I've had to convert to an F vector because it seems to be more widely used in transform. For whatever reason, spawn actor wants your transform instead of your F vector. It's kind of fun to say, so feel free to keep saying that. But we can just call it a vector. I'm sure you'll know what I'm talking about. So I prefer to use a vector. You can, by all means, use a transform if you want. Vector, just to me, has always stood out as one that is more easily used elsewhere. So to do that, all you have to do is pull from your player transform and type break, and it'll say break transform. Now, these next three nodes are to make the hitbox location a little bit away from our player. If you see when I attack, it actually kind of looks like it's coming out of where his arm would be, or like where his arm would end, not just the center of our character. That's good. That's what we want. The reason that's actually happening is because of this part right here. So if you break the vector, the location vector, you can actually handle the individual components of it, the X, Y, and Z. Now, you can't change it right here. Like, you can't just be Y set value. Whoops. Set value, or something like that. Well, technically you can do this, but this is not actually what you want. That's for material. What this is doing right here, this plus negative 100, this is modifying this value so that we can make a new vector and then return it to the variable that we want. So in my case, and it could be different based on how you made your Unreal game, but in my case, Y negative, you can always go back and look at your scene, look in the bottom left-hand corner. You can see which direction is which. So if we were facing this way, Y would be positive, but since we're facing this way, Y is actually negative. Does that make sense? And you can see Z, X, you can see all of them moving as I do this. So, I'm basically just manually moving this to the right. 100 is just an arbitrary value that I used because my y-axis and my mutant, that's kind of the value where his body is far enough away from his attack. If I kept it at 0, which we can do right now, we can play it. If I keep it at 0, you'll see it spawns in the middle of his body. We don't want that. We want it to be to the right of his body. And eventually, like I said, we will want it to be dependent on which direction he's facing. But for now, this serves as a well enough example. Good enough example. Okay, so negative 100, make vector, just pass x and z back into it, and then use the new y value into this one. Plug this into your hitbox location variable. Then drag off of your spawn actor that we did earlier to set your proximity type. It'll be a drop down, so you can choose whatever you want. Again, in our case, TAC Started is proximity, so that's the one we want. Hitbox location we just talked about. Spawn hitbox. This is the function I made in Hitbox Actor BP that I was talking about earlier. It calls this and goes through this logic. Again, you could do this on begin play if you want. I wouldn't necessarily recommend it, but that's just the way I happen to think of it as being the easiest. If you find a way easier, feel free to use it. Lastly, I made 2 arrays. These arrays are just variables. This is like Hitbox Actor. So all you do is you click on this like you would to change your variable type any other way, and go to the class instance, because we're getting a class instance, a reference to a class. So mine is Hitbox Actor BP. In our case, we want Hitbox Actor BP. So I do object reference. Normally it will look like this. Then, if you want to change it to an array, you just go up here to the details panel. If you don't have it, you can look at class settings, class defaults. I can't remember which one, if it matters. I think it's class defaults. If you don't have it, we'll bring it up. And then when you click on Hitbox Actor, it will show you the variable data. You left click, just regular click on the little sphere to the right of the variable, and then you can make this selection an array by choosing the 9 squares. We don't need this one, so I'm going to delete him. But I made one that was for the proximity hitboxes and the active hitboxes. This is so I could manage them separately. If you were going to have one proximity hitbox, say, and 3 strike hitboxes, like with the knives or the bombs example I said earlier, well, I wanted them to be separate. I didn't want to have the same amount for each of them. That could cause problems down the line, and honestly, the more flexible you can always be in coding, the better. So all I do is add that hitbox instance to that array. Now, you'll be happy to learn that the active hitbox and Notify is the exact same, except we changed this to a strike hitbox because we want it to be red and be the one that causes damage. And I add it to the active hitboxes instead. There is something else I do here, and this is I clear out the proximity hitboxes beforehand. If I don't do this, it's fine. I'll show you right now. If I don't clear the proximity, it's fine. But if for whatever reason they take place in not the exact same size, you're going to still be able to see the proximity hitbox behind it, which you probably don't want to do. I could be wrong, maybe you do want to do that. If that's the case, then don't bother clearing it here. I do not. I want to go from proximity to active to clear. So in my case, I want to loop through all the proximity hitboxes, destroy them, and then clear out the array. If you try to destroy actors that aren't there, usually that's going to cause a crash. I can't remember in Blueprint specifically if this destroy actor function will crash or not, but it's really not a good practice anyway. So just clear out the array. You don't need it to be getting too full. Okay. Now, we already had TAC ended from last time, but there is one other thing I want to do with it. So, I wanted to clear out both arrays. It's the same exact logic as above, but make sure your proximity is cleared and your active hitboxes are cleared. If they're not cleared, you could have lingering hitboxes, which is an issue we had during Fury Strike, where sometimes hitboxes wouldn't go away. You don't really want that. If that's the case, then it's going to be annoying. You're just going to have a hitbox sitting in the middle of your fight the whole game. It's just not... Why take the risk when you can just do this and solve your problem? Okay. Lastly, I will show you how to make simple materials. I will be going over how to make materials that look more like the transparent hitboxes that you know and love from fighting games today. But I am by no means a materials expert. We can do some basic ones pretty easily. So I happen to have an art folder with the materials folder and a hitboxes folder. All you got to do is you can do right click or add new and do materials and textures. Material. So make 3, 1 for each hitbox. And then if you double click on the file, you'll go to something that looks like this. And all you have to do is type in vector parameter. So if you type in vector, you can hit vector parameter and double click on the black spot here, and then you can select the color you want. We want that color, sure, and then drag it into base color. And you can apply or save. You don't really need to hit apply in this case, but either way is fine. And then there you go, there's your material. In my case, I do actually want the yellow. Whoops, what did I do? I do actually want the yellow. So I'm going to paste it back, but you can put whatever color you want in there. And I'll hit apply again, even though it's not necessary. I'm just used to it. Save. There we go. So that is the entire tutorial. It was pretty quick. I tried to keep it pretty quick, but thorough enough. If you do have any issues, of course, let me know. And the whole point of this is that you guys can learn how to use this properly and feel confident in your system, so hopefully I didn't confuse you at all. But if I didn't, then at least you learned how to make hitboxes. In the next episode, if we decide to do hitboxes again next time, we will make it so that it works with the character direction, and we'll do the bounding box collision between the hitbox and the hurtbox. That way, if a hitbox comes in contact with a hurtbox, the enemy player will actually take damage. Alright guys, I'm Shawnthebro. I think that's it. So if you enjoyed this video, please subscribe. Please subscribe. I'm not gonna ask you I'm not gonna ask you. I think that's it guys. So I'm Shawnthebro. If you enjoyed this video, please subscribe. I'm not gonna ask you to like or comment if you don't want to. But subscribing would mean the world to me. That's what helps me do these videos. This one took quite a bit of time because the hitboxes are more of an advanced topic for at least what we've been talking about so far in this series. But I would just really appreciate it, and it would let me know that you're still interested in watching these videos. So if you have any questions or any requests, please let me know. Lastly, for the Resident Evil Health Bar remake, I am working on that right now. It turned out to be a lot harder than I expected because it wasn't exactly the solution that I intended. I'm adding a bit more functionality to it and making it look nicer. It should be the next video. It took a lot longer than I expected. So thanks for waiting, Robert. And yeah, get ready to see that. And hopefully you guys are still excited about the fighting game tutorials. Let me know anything you want to see. Otherwise, everyone, I'm Shawnthebro, and I'll see you in the next episode.